Okay, so when we talk about science and engineering, yeah, we will deeply discuss about this two kind of the point of view when we see the object of the science itself. So when we discuss about computers, that we know the computer is consists of a lot of component and also element that we need to discuss. So and yeah, we already know that the computer is have a lot of many component and also some module system subsystem and etc. So that's why the complexity in the computer science make and support the computer science as a science. Yeah, so that's we will our discussion actually. Yeah, so let's discuss about it. And okay, when we see the computer science, the first question is computer science is science or engineering actually. So when we when we discuss about it, we have some reference that very main discussion about the science itself. Yeah, yeah, from Kalmer in 1999 say that what is so special about scientific knowledge is that it is derived from facts rather than being based on personal opinions. Yeah, so this is very very in Indonesian way is menggelitik, yeah, or make us curious why a scientific like yeah, we believe that science is something relatively, fixed. Yeah, something has discovered, something has explored, and then something has approved as a fact. And but in same times, it can be see as a personal opinions, yeah, from the scientist. When I see this word, I think I a little bit agree because let's say if I work on the lab and do some scientific research, and then I report the scientific report in the paper on or in the and then I publish into the conference or journals, it seems like actually I share the fact that I found in the my experience, but in same way I also explain about my own opinion about the facts. So when we see this one, so we can see that science is giving the opportunity to us to place ourselves in the science positions. What I mean is we can state our opinion, and then we strengthening our fact founding in the experience, and then elaborate to conclude something that we believe is is new, something like that. So that will be very important, yeah, to see this one. So in here we can see that yeah, if we see this one, so everyone, even you are student, for example, even you are common people, yeah, I see, and the community and etc. have same opportunity to have their own personal opinion about the facts, yeah, and it can be become science, it can become scientific knowledge, yeah. Of course, yeah, this is like yeah, some statement that very fairly in general view, but yeah, what we want to say is when we of course the fact finding that we expose in the report or our presentation, it should be came from the good, and then the appropriate process of scientific using the scientific method, of course, yeah. We cannot say just okay, today I see something new in the street when I go to campus, and then I say this is a new something new in the scientific way. It can't be that one, but it's need to be assessed with scientific method, and that why the fact can be can be accepted by another person in the scientific area, and then we agree that will be in the new knowledge, yeah. So that will be the one that we want to discuss, yeah. So in yours, I won't just we will not like discuss and then agree and then disagree with this statement, but the most important thing is we believe that and the important thing about the scientific knowledge is we derive from fact, yeah, or in the scientific way is fact finding that we gather from the, you know, from the from the experience. So that's why in the science we need to be very you know, honest, yeah, very honest and pure. What I mean is we cannot do some you know, some experiment that manipulate the result. Yeah, we cannot do that one. We cannot claim something that we not find in the our experience. So that will be very important. Yeah, so you need to know that. That's why a scientist we have some the first you know, term that we need to, is mandatory, we need to take in every journey. That is, we need to be, you know, we need to be honest. Yeah, we need to be honest on ourselves. If the experiments say that it's not good result, yeah, we need to say that that is the fact. Yeah, and then we explain why it's happened, and then we analyze why it's happened, and etc. So that's the mean of the science actually. So I'm very agree, if you do some your, for example, thesis experience or experiments, yeah, when you, if for example you learn you run some algorithm to do some prediction using some maybe machine learning or deep learning algorithm, and then you found that fact that your accuracy is not good enough, like before, like the previous research, for example. It doesn't matter. The most important thing is you show your result, and then you explain and analyze why your result became like that, and then that's the science actually. So it doesn't need to push yourself, for example, to have the, the perfect accuracy, yeah, for example. Yeah, so that will be the important things. And in that one, actually we believe that science will be more, you know, accommodate not only just a good news but also bad news in the science. So when we fail in our scientific experience, for example, or experiment, so it's mean, yeah, we need to stay that one, and then we can learn from the failness what actually happened, and then we can avoid for the next of the scientific journey. So that will be the important thing on the first word that we say, that this is from facts. Yeah. And then the next is also the personal opinion. The personal opinion is not only just we say what we like, yeah, or dislike, but the most important thing is we become honest, and then say that our opinion is scientific opinion, of course. Yeah. Not like, you know, just opinion to have more like, for example, something not like that. Yeah, so that would be not to become famous. In now in the scientist world, we have some issue about publication. Sometimes we belong the scientists, we compete each other to have more citation. For example, we need to have more Q1 or Q2 journals level, for example. But unfortunately, what happened next is we do everything that we need to do, and sometimes it's across border. So we can have a very huge reference, and also we can join the Q1 or Q2 journals, but not in the good way. So that will be is not good actually. Yeah. For example, for research in the area of specific area, like in my research, yeah. For example, in the architecture, in the infrastructure, it is not now. It's not easy to catch up the Q1 or Q2, and there is a little now. It's very limited the scientists that can refer that paper, because mostly now scientists, and of course if you ask yourself and your friend, maybe the interest to do the research now is more in the machine learning or deep learning and AI some things, yeah, or data science. Yeah. But how about the network? How about the data center and infrastructure? We have a limited scientists that want to join that area now, and what happened is, of course, the publication is very limited, and then the journals publication is also limited. So that's why the reference is not as huge as another scientist in the AI track, for example, for today. Yeah, so that will be the fact that will happen. So it's mean, but the most important thing, see, if as a scientist, we doesn't need to become famous actually. The most important thing is we become the honest. If I work on the infrastructure and architecture area, yeah, so I will focus on it, and then I will try to you know to do on that way. Yeah, so that's will be the good things. So I suggest you, now you are a student, so you can catch this idea that you doesn't need to follow your friend to take the you know the thesis topics or subjects, but you can find yourself in there, and then you and sometimes you also need to brief to discuss with your supervisor, and then because you have your own interest, you have your own idea, and then your supervisor will help you to find your way, and then how you do that in the efficient and effective way. So that's the mean of the research and science, yeah, and also collaboration. Okay, so what are the facts in computer science? Yeah, yeah, computer are made by man, yeah, by human actually. So in here, is also timeless laws as and physics. Yeah, computer as physics, you can see is changing every, not every years, but more maybe it's in every 3 months or even 1 month. I think. Yeah, we have a lot of models in the computers. Yeah, you can see like in the smartphone, for example. Yeah, it's also happen. Yeah, so the things that physics study happen without scientists. Yeah, so that's within the matters, and do the subject matter of computer science exists without computer scientists. Yeah, uh, so that will be the interesting that we need to think. Yeah, and then to try to analyze more deep. Yeah, so it's mean in computer science there is no single fixed knowledge in that we can freeze and then use for a long time, but it's mean we need to understand that computer science will be changing every day. Yeah, so that will be will be very important for you to see that we are in the very dynamic environment when we learn the computer science. We cannot say that okay, the computer science say like mathematics, that a plus b and then we have c, but yeah, it's changing. Yeah, so that within the matters, especially when we learn some algorithms. Yeah, algorithm is growth and it's always developed every day, because we discovering something new, we discovering some matters that we need to consider, and then we have that things. Yeah, and what is the new knowledge? Yeah, for example, if in biology you observe something new about some organisms, you have added to the body of knowledge. Yeah, so that's also same things. When we learn, for example, now user experience, yeah, on the our area, it will be impact on the some of the human computer interaction component, and also the way how we use the computer, how we made some design on the hardware, and how to use some system or application. So yeah, it's also same like the logic is like in biology. When you observe something new about organism, then you find new organism that never discovered before, and then you will add it to the body of knowledge. So it's just like some plug edit features. Yeah, so that's why the knowledge will be more fat and more big beyond the time. And if in the computer science you observe something new about some system that some great student built, yeah, it's also have question: do we care? Yeah. So actually, is if we go back to the to the theory of knowledge, we will see that it's depend. Yeah, depend how we see. For me, if some great student built something, like say you do your thesis, and then you've done your thesis, for me it's knowledge. Yeah, because even that knowledge is I already discovered before, for example, but for me it's new knowledge, because you have a new experiment in the different time. Yeah, it's at least in the different time, in the different style of the research, in the different environment, and also maybe the different point of view with yourself. Yeah, so that will be uh, uh, the focus here. And of course, the difficulty of defining new research project will be very challenging. Yeah. So this is like, when we see this slide, we understand that the computer science is growth, and knowledge will be depend on the growth itself. Yeah. So that's why, as student, as scientists, we need to understand that the knowledge will be very, depend on us. Yeah. If you want to move science and knowledge in the future is more bigger, and have a lot of impact on the community. So I think it's time for us to push the knowledge in that direction. Yeah. So don't to push the knowledge to be like, only selfish to himself, or to itself, but we need to push to the community, for example. So we go to the next slide. Yeah. So we have also same question: is computer science is mathematics? Yeah. So that will be the question. When you see in the mathematics, it's like, the the area of discussion about number that have some, empirical patterns, and then also have some 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 logic way to proceed or to compute something, and then we have some conclusion. Yeah. So when we see that one, it's mathematics is not an empirical science. Yeah. Why we call not an empirical science? Because it's very complex science actually, because we need to do some, some differentiation. We need to do some, some logic way to solve some problem in the mathematic way, in the logical way. So and then and also mathematics will be growth based on the humankind. Yeah. So that it's about man-made object and concept. If we want some new concept, yeah, of course will be new mathematic way. Yeah. So for example, in the mathematic way now, we have formalized, formalized method, for example. But in same times, we found that mathematics has new concept about the crowd concept, for example. So that's why it's based on the man-made object or concepts. Yeah. So that's why it's same with computer science, actually. Yeah. So that's why many would agree that computer science is mathematics. Yeah. So that's why also the computer science and mathematics is very close. And in another word is mathematics will be pushed, or have the enable, pushed and be the enabler of the development of computer science. The proof about it is you can see from Turing, Dijkstra, Nat, and etc. that uh, develop something new about mathematic model and etc. For do some computation things. Yeah. So that's why, and then based on the mathematic model, he become algorithms. Yeah. Dijkstra is one of the most yeah, especially used for network, yeah, for networking and so on. But actually, it's not only not network, but also in the business now. Dijkstra is also used for many solutions. Turing, yeah, itself, yeah, it's very foundation. Yeah. So there is a strong mathematical tradition in computer science. Yeah, we cannot disagree about it, but I'm very agree with this one, because a lot of mathematical concept that we try to implement in the computer science. Yeah, but nowadays it's clear that mathematics is no longer fundamental for many computer science activity, because now we think about more than just mathematics. Yeah, we also implant the, like say the evolution of the, artificial intelligence that we see in the bioinformatics things. We have neural networks algorithm or something. Yeah, it's inspired by biology, and we inspired by human, and we inspired by living things. Yeah. So that will be one of the our discussion too. Yeah. And now we came with the discussion about is computer science is engineering. Yeah, so that's we see also some of the some of discussion that we need to discuss. Yeah, yeah. So this one the engineering is about making things, not about explaining the world. Yeah, the explaining the world is about science. Yeah, about explaining the phenomenon, explaining about the fact, what happened. So we explain about it. And then the scientists built in order to study. The engineers study in order to build. Yeah, this is from the Brooks in 1996. Yeah. So in here we can see a very fundamental differentiation between science. Yeah, engineering is more focused about develop or making something from abstract into the physical things. Yeah, from concept into the real things. So that will be the engineering, because we will also discuss about the practical things, about the functional element, uh, and also other aspect. Yeah, yeah. And then many computer science researcher will build system and then test the system as such, just like engineers. So you can see in the computer science, we when we have a concept, yeah, we have some, some of the logical thinking, and then we build into algorithm, and in the next process is we try to test in the real system. We do some heavy load testing in the, maybe in the network. We do the penetration test in the big data processing. So for example, we proceed a huge volume of data, and then in the many area we do something like that. Yeah, like that. Yeah. So actually in that phase, we do like as engineers here. Before, right, we try to, to explain the fact in the scientific way, is we are the scientists. But in the same times, after that we implement the concept. It's mean like we like the engineers make something that we has developed the concept into something that works. Yeah. So that's why the system compromise man-made computers. Yeah. So yeah, this is about the nice thing, yeah, to be in the computer science. Yeah. So in here, I think, yeah, you maybe, if you, for example, you are computer science student and mostly your focus is only on the designing some fact into the concept. Yeah, for example, in the sum of the abstract. Yeah, it's mean you are the computer science. But if you go to the pure, yeah, I mean the pure computer science, but you also do something, do the experiments, prove something that from your concept into the implementation to the system, you go to the engineers. But the engineer, it don't do like us. Yeah, they're not working on the algorithm. They're not working on the creating the concept, for example. So that's why it's different. But I think it doesn't need to be, to be again about the science and engineering. But the most important thing is how we can collaborate with others here to make it happen, and then and works for community. Even, yeah, the mathematics say that for especially for mathematical technician, is computer science is no more about computers than astronomy is about telescopes. Yeah, that's in the science. Yeah. So in here, yeah, you can see from the basic concept, the computer science is different with the computer engineering. Yeah. So when we see this one is in the very clearly, computer science is sort of like math, yeah, sort of like science, yeah, and sort of like engineering. So it's like data science, yeah, for example. Like data science is one of the area that not only discuss about the data science, yeah, but sort of like a mathematics, sort of like a science, like sort of like of engineering. Yeah, yeah. Same with computer science, yeah. So this is why it seems so all over the place to outsiders. Say, look, look at our faculty, and then nobody on campus can understand what we do. It would be great to be able to tell him, and etc. So yeah, it is very important to see. And then the computer science is a loosely connected set of computing center field and just an umbrella. Yeah. Even this is that's not useful. Yeah. So that will be very our our attention on this discussion. So when we see the definition itself, yeah, the study of phenomena surrounding computers. Yeah, this is from Newell's Perlis Simon about when they try to describe is what the computer science is. So this is described what computer scientists do, but if computer are product of computer science, that it's a circular definition. Yeah. So it will be important to understand that when we see this one, the computer science is the study of phenomena surrounding computers. It's mean, yeah, we see the computer is a product, yeah, engineering product of computer science, yeah. The computer itself, the form of the computer, the product of the computer. So this is within the circular definitions, yeah. And also like mathematics, it's what mathematicians do, yeah. So mathematics is the product of the mathematicians, yeah. So that will be very important things to see in here, yeah. And the computer science is the study of the theory and practice of programming. Yeah, this is from Khalil and Levy, 1976. Because yeah, most of us maybe have some 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 construction that computer science is mostly like programming. Yeah, so this is will be very important. Yeah, you can see in this we have a lot of differentiation when we see the to see the computer science process. Yeah. And we also have the Hemming, yeah, that believe that it's important not to ignore this question, what is computer science, but the idea, well, to just get on with doing whatever it says we are doing, yeah. So this is will be very very important to understand that we need to see this is it doesn't matter to what I say, it's not doesn't matter we want to talk this is computer science or not, but the most important thing what you are doing in that, yeah. So that will be that will be very important for us, yeah. So the thing is when we see this one, we need to see the pictures, the picture or point of view when we want to see the problem on definitions, yeah. So when you study the computer science, you need to see that computer science have a lot of diversity, yeah, diversity of the field and the challenge that diversity bring with it, yeah. So a lot of differentiations in the point of view, and maybe like difference of the entry point to discuss about it, yeah. So when we see this one, I think this is the opportunity and also the potential development of computer science itself, yeah. Because the argument will be help us also how computer scientists should work have fruit in the different conception about what the field is, yeah. So it will be very very interested to understand about it, yeah. So so that's why when we for example read the book about the computer science, we will have a lot of some of the conception that have a different point of view. When we see, for example, big data or artificial intelligence, or maybe some of the new technology that came to us now, of course, different computer science we will have different definition. So it's very natural because yeah, the diversity is inside already exists in the computer science. But the problem is if the differentiation produce many misunderstandings and also controversies. So that will be very difficult to explain. Yeah. For example, like AI now, artificial intelligence. I think if we are in the computer science, I think okay, we have a same direction. But if when we discuss with another people from another discipline or another area, they will have their own conception. so that will be very make us misunderstanding, and of course in same way we have the controversies. Yeah, so that's why like today the artificial intelligence in us in our computer science maybe can help us to to produce some potential approach on the medical, but unfortunately the person from the medical maybe we can see that they still have a lot of question about the methodologies about why AI can replace the human thinking and so on. So that would be very fundamental to see this one. So and in same time actually it's okay because that's the misunderstanding is natural, and it can be there in many way. Yeah. So to avoid that one, we need to back to the philosophical tradition concept that we discussed this one. So that's why this course is very important because it will be like be your way to your way the way back, yeah, to see the place how we want to understand upon the concept. Yeah. So but unfortunately the like this course is only for you as computer science student, so that's why it's very but yeah, of course we cannot force another student or another people that not in the computer science to join this class. Yeah. But at least as your computer science, when you see a differentiation with your friend, for example, at least you take it easy, and then you can bring the discussion into the philosophical way. Yeah, not only to technical. If in technical we have a lot of misunderstanding. So that will be very important. And then it will be very difficult to come up with the common understanding how research should be done. Yeah, so that will be also our discussion. And then like us in our computer science department, we also have a same problem. We have a lot of people, for example, the lecture from many background, many interests, and then we are in the same floor, and then we have discussion. So it will be have a lot of differentiations. Yeah. And then some philosophical question will be occurs when we have this problem. Yeah, for example, do computer science proof formula like mathematicians, build things like engineers, test hypotheses like scientists, do all the above and do something else entirely. Yeah, so I think the question is not only just question, but it describes also what actually computer scientists do. Yeah, we do like formulas, formalizing the mathematical things. Yeah, and we also need to build things like engineers to have the environment to do some experiments and then test the hypothesis. Sometimes I have hypothesis that if I add some resources in the computations resources, it will be impact on the speed, but unfortunately not. So my hypothesis is failed, for example. And also do all the above. Yeah, and also we do another else. Yeah, so that will be also the issue. Yeah, so that will be very important to see there is a problem in there. Yeah, so and what we see is what is progress in computer science. Yeah. So uh, we sometimes I have also have question, what is the progress today, what are the progress, so we need to see this one. So why we need to see this one? Because based on that that progress, it will be help us to see what actually happen in the computer science itself. Yeah, so that's why it's very important to see the current development of the to see what the current landscape of the computer science, what the current discussion of the the current discussion in the development of the computer itself. For example, in many discussion like in the supercomputer area, is like discussion is about the speed and also the capabilities of the facilities to compute something big, something like that, yeah. And if you go to the Turing Award recipients, you can see there is more more scientific, yeah. So there is a Nobel Prize actually in the computer science, and there's a new algorithm or program progress, yeah. Do you found something like new in the algorithms, yeah. So if we found that one, it would be very easy for you to see how the computer science work on the algorithm development, yeah. But unfortunately, the algorithms, I think mostly the development is slow, but the slow is not like slow, but slow because is need more more process to develop new algorithms. But when we came a new algorithm, basically will be impact to a lot, yeah. And then will be impact a lot in the computer science field. And then how does new knowledge about computing become a part of commonly held knowledge about computing? Yeah, so that will be very important too. And then what kind of things in computer science are universal, objective, and timeless? Yeah. And then are algorithm abstract or concept? Yeah, is everything because it's everything a computers. Yeah. So it's just like some of the question that maybe you need to remember, and then when you see if you want to see what the progress of the philosophical question to the computer science, when you see our work in the computer science. So I would like you to after this, yeah, after this, I think I would like you to do that activities. So in the philosophy of computer science is not well developed today. Yeah. So we now more move forward on the applications. Yeah. So most of us working on the applications zone. Yeah. So in the artificial intelligence, we want focus on the how using the artificial intelligence to solve something. Yeah. But in same time, it's also important. But when we take a look at the computer science itself, now there is a very limited person that's still interested in the philosophical way. For example, why the artificial intelligence is always like that, yeah. So it's why the form is something like that, and then what happened, and then we need to see what we we'll see how we have this idea, yeah. And then let's see, we can see that when the computer science is when we see this one, so we need to discussion about the tradition of computer science, yeah, from the mathematics, science, and also the engineering, yeah. So when we take a look about the computer science discipline, so actually is yeah, of course the computer science have history, yeah. So let's say what is the first computer? We can see that Leibniz, Pascal, yeah, Babbage, Ada Lovelace, Chuck Loom, Zeus is one of the first scientists that try to engineer the computer first, yeah. But we also have the question: is the first stable part of GSS built? Yeah, so that will be the things, yeah. So when we see this one, we can find that the first invention on the computer science is about the paradigm. So let's say like the Turing machine is came from the Church Turing thesis here. So that will be the Church Turing set up the first paradigm of the how the things of computer science, yeah. And then we also have von Neumann architecture. This is the first Turing complete machines, yeah. So we call the ENIAC, yeah. So that will be he developed based on the Turing machine concept, yeah. So it's also how this happened. In here we can see that Church Turing thesis mostly work on the science and mathematics way, and then the von Neumann's working on the engineering side of that one. And we have the first Turing machines, yeah. So when we go to the HCM publication, is yeah, we have they have a lot of definition also, yeah. Yeah, the computer science can be profession, computer engineering, numerical analysis, and then data processing specialists, and etc. So yeah, it's like let's say like history, yeah. So that will be the subjects, yeah. So yeah, we can see in the decade of 40s and 70s, we see a lot of computer become become famous, and then in 46 we have the first society for computing professionals, yeah. This is like they call subcommittee on large scale computing, yeah. This is part of the American Instrument Electrical Engineering, and then and it's become the ACM is 47, yeah. So when you hear about the ACM, is one of the oldest, yeah, associations computers in the world, yeah. And then we also have in 51 the IRI, Instrumentation Radio Engineering, yeah. This is for electronics computers, and then we have emerging and then become the IEEE, yeah. So that will become the IEEE Computer Society, because the IEEE will be focused on the standard and hardware, but the ICM will be see the theoretical computer science and application. So from here, actually, we have a discussion, yeah. So if we have a lot of computer scientists that work on the publication literature, mostly on the IEEE, yeah, actually they become like the engineers actually. If we want to use this discussion, yeah, this point of view, but if we publish on the ICM, mostly on it is for the theoretical computer science and applications, yeah. So that will be, but yeah, I think now the ICM and IEEE merge together and then bring a new landscape on the coverage of the computer scientists here. So yeah, that's the history. And also the 1950s, the ICM suggests name for people in the field, yeah. Turing engineers, Torologists, flowchartsmen, yeah, a lot of things here, computologists, hypologists, and etc. So in 1960, we have a very hot debate about the name of the field, yeah. So, but in the late 1960s, and the name computer science has been accepted, yeah. So that will be, so the first computer science department is in Purdue University. So that's will be the things, yeah. And in 1965, note is say that I suppose the name of our discipline is an of vital importance, yeah. Since we will go on doing what we are doing no matter what is called, yeah. So after all, other disciplines like mathematics, chemistry are no longer related very strongly to the etymology of their names, yeah. So I agree now, because it's like, you know, some things like it's changed, yeah. It's changed now. So it's like especially when we see that the discipline is not only in the matter of our own discipline, but uh, uh, and what another things here. So that will be very important to us to see this one. Yeah. Okay. Okay. So this is the first official definition. We have that one, yeah, and then if we go to one definition, we also have another definition from Alan Newell, Alan Perlis, Herbert Simons in 1967 that say that wherever there are phenomena, there can be assigned to describe and explain those phenomena. Yeah, so they're very important. And then the simplest and the answer is what is botany, for example. Botany is the study of plant, and zoology is study of animals, astronomy of the study of star, and so on. So phenomena breed science, yeah. We are computers, so computer science is the study of the computers. And the phenomena surrounding the computer are very complex, yeah. So the computer science is the study of the phenomena surrounding computers. So that would be, yeah, the general definition on it, yeah. And in this definition, lead toward empirism, yeah, because we need to observe theorize, invalidate, and repeat, and then implement two algorithms, compare them, and draw conclusions. Send packet through the internet, compute node degree, observe power laws, and draw conclusions. So that would be definition lead toward empirisms. Yeah. So do you have any discussion or some idea after I explain until this? Please, if you have any question, you can say to me. Okay, no question? Okay. Okay, we have a question. This is from Dean Aji. Okay, if computer science is meant to be objective, would that work well with the subjective nature of philosophy? Yeah, okay. Anyone have the response for it before I try to discuss about it? I think it's a good question. No one idea have idea about it. So this is good question. Yeah, if computer science is meant to be objective, yeah, of course, yeah. I think computer science is meant to be objective because when we see this one, we try to explain about the phenomenon surrounding the computer. So it's mean when we want to explain the phenomena surrounding the computer, the main objective is to be honest and objective. Yeah, the objective is mean we let and say based on the facts, yeah, based on the real fact that we found and capture in that moment, yeah. Still, we have some limitation on the moment because it is within the time series things, yeah. So, for example, if we explain, for example, today, not today, this time, yeah, my the performance of my server is like this one because yeah, I have a huge file processing, so it's mean now the resource becomes stuck. So that will be the phenomenon. If I want to gather as knowledge or science, so I have some formula that if the load of the computer is big, it's mean the resource will be consumed a lot and then make it the computer lag, for example, like that one. So but it's only happen when, yeah, when I do the experience consists of this kind of size of volume of file, and then this is the hardware, this is the environment, and then this is how I do the experiments, and then this is the result, something like that. But would that work well with the subjective nature of philosophy? Yeah, I think not 100%. Yeah, or maybe about, yes, 50% it will be work well with the subjective of nature, because sometimes the 50%, sometimes like this one, the scientist, when he say about the problem that I found, like my story, my previous story, I think I will not to explain to you about the failness, the problem that I face in my computation process, but I want more to describe about why it's happened. So it's like subjective from the scientist. So that would be not work well actually. Yeah. So it's mean like, okay, I will say that I'm not okay, but I will try to say I'm okay in another way. Yeah, something like that. So that will be the nature. So if you found like literature or paper or journal that say that I have experience like I have experiment like this one, and then the result is good enough, it's very impressive. You need to see the point of view of the authors. Sometimes the good is not good, yeah, because sometimes it's good is only good for that environment, but unfortunately when we use that, it will be disaster. Yeah, maybe I have a lot of question with my student some, when discuss about the work of the thesis, for example. They always, the student complain to me, sir, I already use this algorithm. This on that research say that is the best performance is in here. But unfortunately, when I follow the research, I follow the guideline, and then I do in my own environment, it's not that kind of good in that previous paper. So what happened? So we will think about, okay, I think maybe I have some error in my configuration or something. Yeah, maybe it's one point. But another point is we realize that the research report that we use is only work for that research. It's not maybe it's not work for us. So that will be your challenge. So that's why the subjectivity on the nature of philosophy is always there. So that's why is, yeah, I say that it's work well for something, but it's not work well for another things. Yeah. So hopefully you can catch what I mean. Yeah. Okay. Thank you, Dian. It's good question. Okay. Yeah. Okay. Thank you. Okay, so I will maybe the discussion I will postpone until next week. But today I will ask you to do something. Yeah, after last meeting you present me about the artificial intelligence. Now I would like you to, based on your group, yeah, based on your group, the previous group, try to discover the new landscape of computer science. You can go to the Turing Award, you can go to the some frontier development of the computer science in the world from many resources, and etc. So if we I need you to capture that one. So let's say I will try. Yeah. So for example, like Turing Award. Yeah, this is the Turing Award. I think I will. Yeah. So and for this one, for the year of the award. Yeah. Yeah. So this one is this Turing Award, for example, in 2000. This one the latest year, Catmull and Edwidge year. Okay. So that would be like uh, Edwin Catmull, yeah, from United States. He have fundamental contribution to 3D computer graphic and the impact of computer-generated imagery or CGI in filmmaking and other applications. So I would like you to explore this sources, and then capture maybe about, yeah, some of the maybe 3 or 5 latest innovation that have these things, yeah, and then please learn from it, and then you make some presentation to explain what actually for example the Catmull and Hanrahan do, and so that's why they become one of the scientists that have awarded in this one. So that you can see in here, for example, from the pioneer of modern computer graphic recognitions. We can see that one. You can see in here, yeah, the biography, and then what he do, and maybe one the point that maybe make they become the awardee, and so on, and etc. I think not only just a Turing Award, yeah. So we have seen the computer science frontiers, yeah. So you can catch from here, and then see what happened from the Springer also, and etc. So you can gather from many so many sources that's for you is, I think it's good enough for to discussion, and then say what do you think about it. Yeah, actually, like UGM also have some award. Yeah, from example, last year, our lecture from physics, yeah, Pak Prof Kuatriana is already awarded as Universitas Gajah Mada award. Yeah, he have some innovation on Genus, but using the artificial intelligence. So you can also mention about it. It's okay, but you can capture the sources from the internet using from the another country or from Indonesia. So yeah, we also have Indonesia have Habibie Award. Yeah. So let's see. I think it will be very good. Yeah, if we can see in here. Yeah, you can say from there, and then you're looking for the award that address the field on the technology and scientifics, and then you can explain to us, to me and to your friend. Yeah, I think you need to do with your friend and then make some good presentations, and then I will let and give you some time and then some space for you to present next week. Yeah. Any question about this task or assignment?